Welcome back, everyone, after a pretty long delay due to myself. We are back with the episode 8 of the Open Source Sports podcast titled Grinding the Mocks. My name is Ron Yurko.
And I'm Kostas Pelekrinis.
And we're very excited to have today join us finalists from last year's Carnegie Mellon Sports Analytics Conference, Benjamin Robinson. Ben is a data scientist living in Washington, D.C., and the creator of Grinding the Mocks, where since 2018, he has used mock drafts, wisdom of the crowds, and data science to predict the NFL draft. He is a 2012 graduate of the University of Pittsburgh, go Panthers, with degrees in economics and urban studies, and earned a Master of Public Policy degree from the University of Southern California in 2014. You can follow him on Twitter at benj_Robinson and find the Grinding the Mocks project at grindingthemocks.com and at Grinding Mocks. Thank you, Ben, for joining us.
Thanks for having me. I'm excited to be on.
As I said, it was long overdue, given that you were the runner-up in the last year's Reproducible research competition. So one of the finalists gave an awesome presentation, and I'll say it was an extremely close finals. It was, again, though, a great entry and hopefully very inspiring for other people to compete in the competition. We'll talk about that later on. But to get started, give us a motivation background of this project, because you are basically now the mock draft person in the NFL. From people going on Twitter, sports analytics community, everybody knows who you are from doing mock draft work. So what started this all?
So it all started at my friend Blair's apartment in Oakland, in Pittsburgh. So my buddy and I were, big. He's a Steelers fan. He's, big Pittsburgh guy, and I'm from Cincinnati, and I'm a Bengals fan, kind of. And so the main thing that kind of brings us together was the draft, just kind of a fun way. It's kind of an exciting time of the year. We know that the NFL has, relative, parity, mostly because of the sample size of games from year to year. So the draft can have a meaningful impact on how your team performs the next year. There's a sense of kind of a quality of opportunity that's like uniquely American about the draft, I think, which is like, we can talk about that philosophically at a different time, but it kind of brings everyone together. And so he and I were sitting on the couch, so to speak, and we're hanging out and listening to some of the draft pundits talk. And as a lot of people who follow football know, the draft talk kind of can get really out of hand. And so as someone who's kind of an analytical guy, I had majored in economics, social sciences, I kind of had this question eating away at me as, how do we use information? How can we kind of cobble together some way of understanding when a player is expected to go? And then we can kind of be more kind of articulate and kind of better understanding of what happens in the draft, because otherwise you can just say whatever you want to say. No take is too extreme. And so I kind of was interested in kind of putting some data and reason behind that. And that's where the project started. And so some things kind of confirm some of the conventional wisdom that you hear, like, oh yeah, that guy went way earlier than expected or way later. But there's a lot of gradations inside of that too. And so it originally started as kind of a way of thinking about how to think about the draft in a way that made more sense to me than just kind of reading a single person's mock draft. And so I kind of thought that applying like a wisdom of the crowds approach would be a really interesting way to approach the question and the problem that I had in my mind. And that's kind of how the project began, and it's only kind of grown from there. I kind of can't believe it myself.
Very cool. So you talk about using wisdom of the crowds, and I think the first thing we want to start with, and so for people listening, what we're starting with to guide us on the discussion of Ben's work is actually his paper from last year's Carnegie Mellon Sports Analytics Conference competition, Grinding the Bays, a hierarchical modeling approach to predicting the NFL draft. So I think it's very relevant, and also we've kind of done a similar process in our other episodes of going through just the data to start with. All right, and it's pretty interesting here because you did a lot of data gathering yourself directly. So can you describe that data collection process? What are the different sources you're collecting from? How are you actually doing it? And also, to make this question longer, how often are the data actually updated?
Sure. So the Carnegie Mellon Sports Analytics Conference paper uses kind of proof of concept data that I collected in 2019 about the 2018 draft, because I didn't just kind of go knee deep in to say, hey, what happened? I kind of wanted to take a look at some of the old data and see if this was helpful at all. So the data itself today is collected from a lot of different sources. There's a lot of different aggregators out there of mock drafts. And in 2018 and 2019, most of the data that I collected was hand. So I do it by hand. Over the years, I discovered web scraping, and I've gotten, I think, pretty decently good at it. So nowadays, most of the data I collect is, via an automated like web scraping in R. And so it kind of varies in terms of how often I'm collecting data. Mock drafts are pretty few and far between right now. And so I am interested in getting kind of a little bit of a taste of what people are thinking now, although some of the past research I've done has shown that the opinions right now are definitely not as good as they are later on. So the data during this point of the off season, I probably am doing data collection every couple weeks. And then after the season, college football season ends in January or so, I'm collecting data about every week. And then as you get closer to kind of the combine, it gets, kind of closer and closer to the draft. And then in the week of the draft, or maybe in the month leading up to the draft, I'm kind of collecting data every day. The data usually gets updated on Tuesdays on my grindingthemocks.com site, because there's this kind of meme on draft Twitter of mock draft Monday. It's the alliteration probably factor. And so that's when most mock drafts get posted. And so you kind of want to get a sense of what most people are thinking. And so doing it on kind of a Monday cadence is probably what I'll do throughout the year. But yeah, updates usually happen on Tuesday with data from Monday when I do update the site. But during the season, I don't want to get people too caught up in the horse race of the data, because it can change a lot of the time, and there's not necessarily always some good rhyme or reason, or it's just really complicated to explain. So I think this year I'll do it on a more regular cadence so that it's just kind of easier for the public to kind of digest. But yeah.
Yeah, so actually following up on that, do you have a specific set of people or media networks that you follow their mock drafts, or do you now use the aggregators and whatever they provide?
Some of the media ones who I really want, who I think are who have historical accuracy or are thought leaders, I like to have their data. So for some of them, it can be hard to find. Like there's some people who've gone from posting open public things to posting paywalled things. So I have to kind of usually go on to find the ESPN guys. Sometimes you have to go into weird Reddit holes to find some of their data. But for the most part, I'm looking for people who kind of publish for established publications, or at least are trying to be putting out predictions often, because it makes it look like they're, at least to me, as a signal that they're at least paying attention and updating their priors or their kind of amateur scouts to a certain extent. I'm interested in getting a broad base of understanding of what the community is thinking, not just a subset of that. And sometimes if something is kind of, I'm not going to grab anybody and everybody's thing, but there's not necessarily a great filter in terms of what I include and what I don't include. And people have asked me that, do you have a threshold for things? And mostly I don't. And the main reason why is that I kind of want to keep an open mind about what data I'm collecting, just because there's a lot of unknowns when it comes to the draft. And when you're making a prediction, out of sample once every year, I tend to kind of not want to go too overboard, but kind of try to strike a balance between collecting data that I think could be helpful and data that's kind of interesting, is going to tell me something different sometimes.
How often do the experts and wherever you're searching to gather these mock drafts, how often are they updated? So you talked about updating your site, but how often does someone, what does Todd McShay, for instance, okay, maybe that's a poor one to use, but he's the first person that pops in my head for some reason. Todd McShay or Mel Kiper, they make their mock draft. How often do they update them throughout the year? And does it, I'm assuming, right, like the updating process takes place a lot more in, peak draft season mode, but what's it like
Definitely.
right now?
Right now, the experts are not really putting out that much content. They might put out one preseason mock draft, really, just of guys that they think are interesting or could be first round prospects. Unless you work for a site that's specifically draft focused, then you might put out some. But really, right now is a very quiet time. During the season, you might see some, but from a guy like McShay, you probably won't see one until the end of the college football season. And then you probably will see one maybe after the combine. And then you might see some leading up to the draft and then one right before. So most of the high-end experts maybe will put out 5 mock drafts at most, maybe 6 if there's something like, last year there was the big trade between the Miami Dolphins and the San Francisco 49ers, where a lot of people wanted to react because it kind of so shook up the kind of draft landscape that people felt like they needed to react to it. If there's something like that happens, you might see some more mock drafts. And that was something where I was like, well, I got to spend like a Wednesday or whenever it happened just collecting data so I feel like I can have a response. But yeah, for the most part, most experts, and that kind of makes it a little complicated to use the expert subset of the data because there's just not enough predictions in there, not enough mock drafts, and not enough longer mock drafts for them to really have predictions on players going into maybe they might reach the end of the 3rd round, which tends to be around pick 100. Whereas the crowd of the fans, they tend to be a lot bigger, and so you can kind of there's more useful data in there to predict the draft in the long run, like all the way up to the end of the draft around pick 250.
So I also guess that earlier mocks have a different objective in the sense that it's more who is the best player, whereas closer to draft is more also, okay, which team is picking 8th? They need a linebacker or things like that.
Exactly. I think right now, number one, my advice to anyone who's listening to this, obviously not necessarily anyone who's like in a draft community necessarily, but they might. And I always say, don't get too upset about a single mock draft because in this early time, they're just putting out ideas about what kinds of players might be first round fits or players to watch, or like players that they think if they have the right season in college could be on the radar for later on in the year. No one gets any points for being earlier on a player than everybody else, really. So it's a lot about the scenario building at this point. And then I think, as you're right, as we get more information in the kind of draft season and the process around, what their needs are, there's free agency, potentially there's a regime change and someone might want to draft a quarterback. We get more information as we go on. And so you end up with higher quality predictions later on because we just have fuller information. And that's just kind of a, classic, economics and social sciences idea that the closer to the event, ideally the prediction should be better because you have more information in the marketplace, so to speak.
I'm curious, how far back have you collected data on mock drafts?
So the 2018 year is the earliest that I have data on. That was kind of not a full-fledged data collection. It was just kind of a proof of concept for me. And that's what the focus of the paper is. It's just on using this data from 2018. And you can see why in the paper, I saw a lot of promise in it just from that 1 year's worth of information, that there was this like pretty decent relationship, even in the smaller sample of data that I collected. And that's kind of what pushed me to say, 2019, I should do this, and then 2020 and 2021 and going into this year. But 2018 was the first year I did it. And I think that's because it was the closest year to the draft. And so if I was going to look back at 2017, you're going to be harder and harder pressed to find links that are still active. And so it just made the data collection process easier to start in the year closest to the time period that I was in when I started this, which was in 2019. So looking back at that most recent 2018 draft.
I was wondering actually, I guess we'll transition here into methodology actually in the paper. But I was just thinking when you're describing this. And, the adjustment of the mock drafts once as you go through the season and you start to know, okay, which teams are picking when. And I was just thinking of, okay, the change in how maybe teams and whatnot, people perceive different positional value. And I wonder if you looked at mock drafts from like 2005, 2006, how do those predictions change versus what we're seeing now? I'll be curious if you decide to maybe one day approach that, or if a listener wants to reach out to you about maybe teaming up on that. That could be pretty interesting, collecting old mock draft data.
Yeah, there are some people who do it. It's just harder and harder the further you go out. You end up with like a much smaller sampling of mock drafts, and this partly the explosion of the internet has kind of equalized in some sense, given people platforms, people to post things. So I mean, there's a famous reporter. I mean, the best mock drafters used to be reporters. There was a guy named Rick Gosselin who worked for the Dallas Morning News. He still represents the Dallas area, I think, for the Pro Football Hall of Fame and the Pro Football Writers group there, I think. And he had one of the more noticeably like accurate mock drafts just because of how plugged in he was. So there were some reporters back in the day who, teams were looking at their mock draft and saying, that's what we think is likely gonna happen, or maybe a couple. And so in the age of the internet and all the things we have out there, I think the data-driven approach is necessary if you want to take that wisdom of crowds approach, because there's just so much to choose from. How do you weight one source over another? And that's kind of what comes back to the motivation. Was I would look at a certain mock draft and I had no idea whether it was any more valuable than another person's mock draft. And so part of this was kind of wrapping my head around how do you ask and how do you answer that question. And in terms of like the shifting like landscape around positional value, I think it's definitely changing. And I think as people have noticed that the NFL is changing to that, the mock draft landscape changes too. I mean, I was going to talk about this at the end too, but we're seeing that even in early 2022 data around quarterbacks specifically, where this draft cycle, there's about twice as many quarterbacks than in your average draft cycle that are kind of expected draft position eligible. So they have enough of a sample in my data that I'm actually making predictions from the mock drafts on them.
Oh, wow.
And so, yeah, there's quite a difference this year versus in previous years where you'd have 5, and now I have 10 or more players who people are thinking, hey, that guy could make the jump of players that have happened in recent memory where we don't know about them coming into the season, and then come next April, they're a first round pick. So I think there's both a kind of wanting to be early and try to be thoughtful about what's happening overall, like that we don't know as much as we think we do, and that the NFL is interested in drafting quarterbacks because they recognize the value of the passing game. We've seen that with wide receivers. I mean, obviously it varies by the class, but in each of the last 2 classes, we've had a lot of quarterbacks drafted, a lot of wide receivers drafted. So yeah, we can talk about it later on about kind of what's different about this draft class so far from the early data, just kind of what people are thinking.
Interesting. Okay.
Yeah, and some running backs in Pittsburgh.
Yeah. Yeah.
All right, so let's focus on the actual methodology here, and so let's be explicit to start with. All right, what in your approach here? If I have the data set, what is a example row of the data you are using for your modeling? What's the response variable? What are your covariates, the features that you're using in your model? Lay it out for us.
Sure. So the data is longitudinal data. So we're capturing the year of the draft because I have a different model for each draft year. We're collecting information on the kind of the writer of the mock draft, the publisher, who they are. We were collecting information on when the mock draft was published, and we're creating a like inverse linear decay function to create a weight for each mock draft. So, for example, today we're about 250 days from the NFL draft. So, 1 divided by 250. So a mock draft that came out today will be rated about 0.004. Whereas, a mock draft that came out on April 27th, the day before the draft, will be weighted 0.5, and mock drafts that come out the day of the draft will be weighted with a 1. So, so that's an important feature, and that's going to be one of our kind of it's going to be one of our independent variables in the predictors in the model. And then we have the names, the information on the player, the pick variable, which is going to be our dependent variable, our response. And then we have data on the player, their name, what position they play, what school they went to, what team made the pick, what kind of mock draft it was, whether it was a fan draft, a media draft, or an expert mock draft. And then we have their URL, just the acts as a unique ID for the data. And then the last feature that's not in the kind of raw data that I'm collecting is a weighting that I give to each draftnik based off of their prior performance, based on their last mock draft that they did. And we'll just keep this to talking about the first round because it kind of varies depending on what round like the predictions are being made in for the players. Because some mock drafters are better or only make predictions on the first round, and some of them only make them on the first 2 days of the draft. So that's the first 3 rounds. But yeah, so the model basically is trying to predict the draft pick selection. So that's our Y variable, our dependent variable is that draft pick. And then we are going to be kind of creating this random effects model in this Bayesian context, using the draft weight as our main independent variable. And we're going to be creating a hierarchical model using each player as a group, with the idea that each player is what we're interested in predicting on, and that each player has an individual journey. And in that journey, we have random effects for the slope of the change over time in their mock draft stock. And we're also creating a random effect for the intercept. So where they come in at the 0. And, there's lots of different ways you could approach this. You could potentially do random effects for some of this stuff, or random effects for none of the stuff if you really wanted to. So there's any number of combinations, not really any number, there's just this limited number of combinations you could use here. And I chose to use both a random effect for the slope and for the intercept because of the limitations of the data set. And it's not about the limitations, it's about the limitations of mock drafts in general. So number one is I don't want to be too certain about the predictions that I'm making. And so I like to have some uncertainty baked into some of the model. And that's why I think the Bayesian approach is really good in this way, because the posterior distribution that we're going to generate from the model allows us to see, to kind of think about the mock drafts and the draft probabilities in a much more broader way than you can in a frequentist approach. But mainly in the mock draft data set, the problem that we run into is a censored data problem where we're really mostly getting first round mock drafts. So, if we had an observation for every single player in the draft pool in every single mock draft, then I'd be much more excited about the data set, and I wouldn't have to worry as much about some of the limitations. But for a lot of players, we're not getting an observation every single time in a mock draft. So to me, I feel less certain about a lot of players' intercepts in terms of where they're starting and then sometimes even where they're going. So there's arguments you can make either way for the approach to be a random effect for the slope, but not for the intercept, a random effect for both. So the approach kind of, when I think about modeling it, I want to be as humble as possible in terms of thinking about what we know. And maybe there's like a argument for certain players, maybe if you have a lot of data on them, you probably could feel maybe a lot better about where they're starting potentially. But overall, I just kind of think, hey, let's be humble. let's just let the random effects apply to both the intercept and the slope. And then in work that I've done since then, I've added a weighting for that draftnik rating. So it's not a term in the model, it's just a weight that gets applied to the model. So it's just not
just to clarify, draftnik, when you say draftnik, do you mean like the mock picker?
Yeah. Draftnik is kind of like the term of art in the industry for someone who writes about the draft and creates these mock drafts. But yeah, the mock draft publishers, the creators. So yeah.
So since you're talking about the effects, the effect types that you're using, you were mentioning in the paper that fixed effects, you don't include fixed effects since this most probably would have been accounted from the mock experts. But what fixed effects could you include? So assuming that you had all this data even beyond what you have, what fixed effects could be useful, you think, for this task?
So what I meant in the paper about these fixed effects is that you could apply a fixed effects for some other things. So I talked about stuff I collected in the data. So for example, you could create a fixed effect for school or conference, or are you a Power 5 school or a Group of 5 school or independent, or any number of those things, or even for something as simple as position. And I think that I think there's a lot more tied up into what the mock draft is. So when I say that a guy is getting picked number 1, I'm usually thinking of that as a person with an important position who has a lot of talent, so they're probably from a good school. And so to me, when I think about the mock draft pick itself, what that number represents, I think it represents more than just one thing. And so I think that the position is tied up in that, in terms of, we talked about positional value a little bit. I think that most players or most people are going to trust performance from someone at a top school versus someone from not as prestigious of a program. They're going to trust what they're seeing on the field as someone who's playing at a high level of competition, for example. I think a lot of that is kind of already baked into the mock draft selection. And so that's what I meant there. So you could add a fixed effect for a position, for example, or even like a quarterback, non-quarterback indicator. But I think that the mock draft captures a bunch of that stuff. And what I'm hoping for is a more parsimonious approach, which means as predictive as possible and as simple as possible. So in this case, that's what I'm talking about. So the fixed effects, I think you could potentially have maybe like a secondary model that could impact those, but I just think a lot of it is getting captured in the mock draft selection. And so I think that adding those in could potentially add kind of covariance or something like that, or create some weird heteroscedasticity that we don't want showing up in the model results.
So okay, so you talked about these differences then, but how did you go about like doing validation for the modeling and, for using these specific random intercepts and slopes at these player levels? So a random intercept for the player, random slope with this variable that's the inverse time to the draft from the point that the mock draft is posted, and then now your inclusion of this draftnik weighting, and so that way, is that included as a fixed effect then? It's
a weight. It's added as a weight.
So it's entered as a weight. Got it. Okay.
Yeah.
So how did you go about your validation process for this? Like, have you looked at how this model compares versus if you just looked at players' position, school, the non-mock draft data, or even things that are like actually like, summaries of their college performance. Have you looked at how that relates to predicting draft position versus these mock drafts?
So I think in terms of like a broader validation, I'd say I've mainly compared it to some of the other the models that I've run. So, at the 2019 Carnegie Mellon Sports Analytics Conference, I did a poster session just using kind of a very simple, much simpler approach, a linear approach, basically, kind of with a local comparison, like a local low S regression is kind of what it's called. And ultimately, the results end up being fairly similar on the whole. Like, I think when I compare some of the simple projections to the Bayesian approach, the results might be a little bit stronger on the kind of lowest regression or the linear regression side in the first round. But you get that positive, but what you lose is a good sense of the variation and the probabilities. So the frequentist approach ends up kind of, I think, giving you probabilities that are way too high. And you don't get a lot of variance just because the sample size ends up being fairly big. And as we know, as sample size goes up, your variation tends to go down. And so I ended up with somewhat accurate predictions, but the variance wasn't there that I felt really demonstrated this uncertainty. So I come at it from kind of a neutral point that we know a lot less than we think we do about the draft. And so there should be a healthy skepticism that we want to apply in our modeling approach. So in terms of outside validation, I don't think that a model based on just statistical qualities would necessarily pick up draft position. It might be in some ways correlated, but I think that you might see some players get boosts in their draft slot projection in a statistics only model. And that's also ultimately, there is a signal in past performance, but that's also getting picked up in the mock draft, right? So like in some ways you could add some element of like past performance based on some of their college statistics. But I think that's also being picked up in the data a little bit. But I haven't done as deep validation to compare it with, for example, other approaches, but I think there's a right thing to do if, to compare different specifications of the model around the random effect, yes or no, or even to other models. Like, I think later on we'll talk about some other approaches of how you could think about answering this problem. So there's lots of ways to approach it. Comparing this to some of the other models, the more simple approaches, I like this one because it represents that uncertainty and it gives you around the same quality of prediction.
So talking a little bit about the specification of the model, but now the specification of the dependent variable. For those that have managed to go through all the episodes, they know that I'm a big fan of any weird distribution / regression that is out there. So you're using the gamma distribution, which is great, but one of the things is that the gamma distribution is continuous, right? So whereas the slot is the slot that the players are being drafted is discrete. Obviously, most probably there will not be huge issues, but have you tried using a discrete distribution, a discrete version of gamma distribution?
So the reason for using the gamma distribution, and I'm gonna blame Greg Matthews for this because I like Greg. So before I knew Greg was a finalist for the Reproducible research competition, I reached out to him and said, hey, I have a question about some of the things I'm doing with this project. Can I talk to you? Because I'm not in school. I don't have a professor I can go to for office hours. And he was saying, the gamma distribution has this kind of property that's really nice. The log of the gamma distribution is normally distributed. I think that's what it is. And so I was like, oh, well, that's what I want. I want something that's way more normally distributed. And so I'll go with that. And you're right, it's a continuous distribution. And you'll see in some of the results in the paper that some of the continuous numbers go below 0 or even less than 1, which doesn't exist in any mock draft. And so any prediction that you make on that looks really, really stupid, because why would you have a prediction that's less than anything? And so, or even a non, whole number. People get kind of shook by that. And so in more recent updates to the process and the model, I now use an ordinal regression as the kind of the framework. So it's, I think, a better approach because the data itself is ordinal. And so you end up the output of the posterior distribution being a ranking as a projection. And so you end up with not only, I think, more kind of reasonable predictions that don't go below 1 or below 0, you also end up with predictions in terms of the probability distributions that more match the structure of the data. And ultimately, well, that's kind of what you want. You ultimately want your predictions. I mean, obviously the posterior distribution, those Bayesian models, they'll put probabilities everywhere. I've sometimes had trouble explaining to people when they're looking at the kind of draft probability curves that I come up with about, why does this player have this % chance of being selected at this pick? And I just have to say that, the model views that as a point where that could possibly happen. Whereas, for example, some players you think like, wow, there's like no chance that player will get drafted at that pick. And I'm like, well, yeah, look, the model thinks there's always a slight chance. And so it'll put a probability here or there. But yeah, so the new approach is an ordinal approach. I think it's way more suited to the problem. But at the time, the gamma distribution kind of felt like a safe approach. But since then, I've made changes that I think have improved what the model offers.
So the point here to remember is that maybe we should go back to last year's competition and see whether Greg did that on purpose.
That's a good point.
I mean, no. We'll have to ask that. We'll have to do a bang the can audit on that. Yeah, some cheating.
So I mean, the choice of gamma originally it makes sense from the context of the gamma distribution is for strictly positive values, and so you're dealing with, even though it's discrete, in actuality, these things are always positive in terms of the draft pick number. But yeah, the behavior was always, I remember in previous discussions, like this was a point people brought up of just looking at why is it a pick number below 1 or in between 1 and 2. But so you've updated that, and now you are predicting using ordinal logistic regression then. So something that is much more complicated to fit, right? Yeah. Gamma regression is actually a much simpler problem than ordinal logistic regression.
Yes, yeah, it's a much more computationally intensive problem too. In practice, like if I had just as much time as I wanted, I'd run the full, Markov chain Monte Carlo approach that I outlined in the paper. But in practice, I tend to use a lot more kind of variational inference techniques, mostly like a mean field variational inference approach that kind of gives you the similar results, but in like way less time. Like at the end of the year, when I have, hundreds of thousands of records that I'm using to power the model will run in like, 2 or 3 hours versus on my little, crappy machine. But the full, MCMC approach, that can run for a day potentially. It's very computationally intensive. I think it's the right approach. So the paper, it's a much easier in terms of computation and in terms of a problem, especially when you look at, how many players across how many draft slots. It's a quite big matrix when you think about it, and multidimensional too.
What are you using for the actual model fitting, like in terms of software? I'm curious.
So it's all being done in R. I'm a big fan of the BRMS package, Bayesian regression. So it's built on Stan. It's a little bit, to me, simpler and like really well documented compared to like, some of the other Stan packages. So for me, I found that BRMS is a nice package. And I think there's also a port of it to Python, potentially. But yeah, BRMS, and it's all built on top of Stan. So I don't have to know any Stan. I just have the R create all the Stan stuff for me. And you do have to be careful about the defaults in there. But I do think that it does a pretty good job of setting up a really nice framework for using Bayesian models.
And I just want to go on the record and say that I hope more fellow economists of Ben, instead of using linear probability models, they use actual probability models.
Yes, good point. So actually then what's related to even then your change in the modeling approach, and I think this is a conversation I've had with you even before at our in-person conference, 2019. People don't know this. I am wearing the shirt actually. Here's to thinking we're going to have another in-person conference in the near future. But what about an actual full simulation process? Because the understanding of what you presented in the paper, and correct me if I'm wrong, if this is still how you're technically modeling this expected pick number for players, the expected draft position. That is just, okay, that's conditioned on this information of this relationship of, they have their own varying intercept, varying slope with this time until draft, and now you have weights with for each of these individual mock draft experts. But what about when you looking at like within the draft itself? All right, what's the new expected draft position for a player given so and so was taken? I'm thinking this in this past draft, right? Given Trey Lance taken by 49ers, how does that change the perception of what could happen for Justin Fields?
Yeah, so you're right that the current state is still kind of agnostic of that. We just have a lot of different probability distributions. And so I kind of like to say that the MCMC approach is simulation-esque, but you're right, it's not an actual simulation approach. That's something I've thought about doing. I think that people might be interested in some of like the data that comes out of mock draft simulators, for example. There's lots of places that have these kind of mock draft simulators, and they're very fun to play with. The problem is that the underlying kind of ranking of players often drives what happens in the process, and they're probably not very stochastic, probably. And so there is an argument to be made of like, hey, if you could create some sort of simulation based off of this kind of simulation-esque data as your kind of backbone, that you could probably learn some things, because the draft is very conditional. As you're saying, I think at certain points of the draft, maybe less, but you're right that they're, especially in the top first maybe 2 or 3 rounds, like the first 100 picks, there's a lot of condition potentially around, hey, if this player gets picked now, there's probably some correlation going on. Kind of like when you look at elections.
That's exactly what I was thinking.
Yeah, and a lot of people have said like, yeah, this is like very Nate Silver-esque. I'm like, yeah, there's some there. My brother is a political scientist, and yeah, he said like, yeah, this is basically kind of a polling aggregation approach, and he's right. Like it's a little bit different, but yeah, it's very similar in some ways to a polling aggregation approach. And if I was going to be doing a live prediction, then yeah, it would be helpful to know in real life that this thing happened, and that could have a correlated effect, because it definitely does. Like you're right, in this year's draft, the data was kind of poisoned around this perception that the San Francisco 49ers were really into Mac Jones, when in fact they were really never into him. They always wanted to draft Trey Lance. And then once that did, you got some important information that the public was higher on Mac Jones than it should have been. And then he ends up getting drafted kind of below expectation, and in some ways, a lot of the ways below what the betting markets had even predicted. They had him at the point where he got drafted, in January, and so there's all this talk, and in reality, his true draft stock, quote unquote, hadn't really changed; just was sentiment. So,
actually, you mentioned betting markets. So betting markets have, similar to over-under for wings, for example, over-under for draft position?
They do. The odds vary quite a lot from book to book. I think the limits on them are pretty low. It's unclear to me how efficient they are, because there's some people who enjoy betting on the draft because they feel like the markets don't do a great job of kind of actually like, I'm not sure how many markets are using like my data to set their lines. I kind of doubt many are. I think they're looking at like a couple mock drafts. You can, yeah, because there's sometimes where I'm not a gambler really myself, but there's some people who will like reach out to me and say, hey, I saw this line for player X over under this. What do you think? And I'll be like, oh yeah, I think that's like, I look at my data and I feel really strongly that that's probably a good value. So But yeah, there is some market out there for draft picks. I just don't know how efficient it is. So yeah,
We can figure
it
out.
could be. It could be. Yeah, you're right. It could be. Yeah.
So going to the point of the conditioning on who has been drafted, do you think that if you want to do that, the framework, the general framework that you have right now is able to do it, or you need to go more to sequential modeling and, model the whole sequence of what has happened in the draft until now?
I think you could potentially use some of the data from the posterior distributions to create some sort of simulation. I think it's possible. I have thought in some ways about the sequential approach that you're talking about. And, if I was going to write another Carnegie Mellon Sports Analytics Conference paper, it would probably be on that. And so when I've talked with people, they thought, this Bayesian approach I think is really cool, and that'd probably be a really good fit. Another thing I've heard people talk about is survival analysis. And I think that's kind of the sequential approach that you're talking about, is kind of looking at this time series element to the data that it sort of exists. And so I think you definitely could kind of apply the kind of properties of survival analysis to the mock draft data. I just haven't done it. And for the most part, I haven't done it because I like what the Bayesian stuff offers. And I don't necessarily think the results would be that much different, but you could get a different angle on on what answers you're getting from the model. So it just depends what kind of questions you're interested in asking.
Yeah, it's interesting. I'll have to think about that more as time to event approach. So something we kind of had this set up for the discussion, but it's actually a methodology now of thinking about the weighting of these draftniks, these experts. So I was curious about how you're going about evaluating them, but now, like, how are you constructing these weights?
So what I've done over time, at first I just took kind of the so I'm really interested in terms of my objective function really here, and I think it's a different one than the person who's making a mock draft. I'm really interested in mock drafters who are kind of minimizing their mean squared error, basically. And so for me, I'm really looking at that type of a metric, an error, like an error compared to residual between expected and between what they're putting and what actually happened. And I'm also interested in being more accurate, closer to the top of the draft with the higher value picks. I think also because if you're wrong there, then you have this like other problem that you were talking about before with correlation. When you miss wrong on a high pick, then everything, all of your other predictions are going to be off because they're in some ways correlated. So, definitely what I'm thinking of is I'm looking at the kind of, in this case, pick adjusted, and I use a logarithmic adjustment to adjust. You can use, a draft pick value chart. I just think it's easier and you end up with very similar numbers when you just use a basic logarithmic approach, and I like it. The natural log is found in all sorts of things in nature, and I kind of like that it applies here in some ways really well. So I use a kind of log adjusted and normalized kind of number based off of their mean squared error. So I get everyone's mean squared error, I adjust it logarithmically, and then I normalize it centered kind of minimum being at 0. So you end up with like a normal distribution of draftnik ratings based off of their mean squared error adjusted for pick quality. And that ends up being the kind of feature engineering that I've done for the draftnik rating for this like mock draft creator ranking. Ultimately, I did it because I think that it helps to differentiate in some ways between it adds a little bit of signal. I don't necessarily think it adds a whole lot. Still think that the main horse is still the change over time in the mock draft stack that predicts. You do get a little bit of a boost, and I use it off of kind of the full history of the data. And so the idea is that over time, you get a better sense, once people are doing this a lot, that they're actually accurate versus just someone getting kind of a flash in the pan sort of deal. And so you end up with, you kind of, in some ways, want to kind of reward people who make more predictions because they're putting themselves out more, and you can also be more certain that they're accurate because they're putting out more predictions. So yeah, the draft nick rating is kind of rough, and it's hard to evaluate experts. There are mock draft competitions out there that kind of give like this many points for an accurate pick projection, this many points to a team projection, and I'm really agnostic. I really just focus on the pick. There's some people who score really well in my ratings, who a lot of people kind of, the community kind of looks down upon. And, I honestly just don't care, because I think a lot of the times people look down on kind of the analysis of why they're making a selection. And I just don't. I don't focus on that. I just focus on the selection. And so when you see it in kind of a less biased way, in that way, I kind of don't care what their approach is over time, as long as they end up in the right place more often than not. And so I want to have kind of a normally distributed residual. And that's something else that you see coming out of the models too, is that the residuals are pretty normally distributed, although there is kind of a lot of interesting variation in between that, for sure, like in anything else we would expect.
So speaking about the experts, it's obviously kind of subjective on how you rate them. Even if you do it automatically, it will just be consistent. But you could have you looked whether there are followers and leaders, so people that whenever someone else gets high on a guy, next week, with the next time they put out the mock draft, they have updated based on that.
There are definitely leaders and followers in the draft community, for sure. Whether it's some of these people who work for major publications like ESPN, like we mentioned, Todd McShay, Mel Kiper Jr., people who work for NFL Network like Daniel Jeremiah, kind of insider types who will write about the league like Adam Schefter. Yeah, like there's definitely a social network at play here. There's definitely some interesting dynamics in there. I'm not very skilled in network analysis, and it's honestly kind of, I think, a really underrated factor in the data. And so ideally, if they're creating noise, but I weight them low, I kind of just hope that like if there's definitely some echoing that occurs. And so if it comes from someone who has a high accuracy score, then I'm kind of a little screwed there in terms of the correlation that we've talked about that exists potentially in some of these places. And so, yeah, I think it's a very interesting social network problem. If there's like someone out there who wants to write a social network dynamic paper on this with the data, like you can definitely reach out to me. It's definitely something that's kind of more intriguing around just the overall kind of concept of what's happening in the lead up to the draft, that you can kind of objectively look at these networks to see how they behave. There's definitely some leaders and followers. I think most people are followers potentially. And then there's some people who are kind of more serious evaluators who like to kind of have their own opinions on players, but it's really hard to be unbiased. And, the wisdom of crowds is based off of the historic example around this, prediction of the weight of a cow. And the idea comes from the fact that everybody has their own independent process in generating their prediction. And we know in this mock draft data that probably doesn't exist, because there's not necessarily, there's some people who probably do have an independent process. It wouldn't be surprise me if the majority of people are more followers. There's not that many leaders. There is something to be said in this world when you're really, really off base on a prediction. Not all of those are going to work out. There's some people who I've actually given probably undue credit in some of my ratings for being, off market, but being right overall. Like there was a guy in the 2019 NFL draft named Clelin Ferrell, who's a defensive lineman from Clemson, who was drafted by the Raiders at the time, very high, like I think the 5th overall pick that I had in my model as being much later in the first round, expected when he would come off the board. And there was one guy who predicted that the Raiders would draft him at that pick. And, then that means in the future years, I'm weighting his opinion way higher because he happened to be right on this one-off thing. And so ideally, in the long run, the more data I collect on the guy, ideally that, model mock draft rating comes down. But yeah, you can definitely kind of improve in my rating system by sometimes being heterodox. But yeah, there's a lot of stuff baked into kind of the data that makes some of this stuff way more uncertain. And that's why I think this Bayesian approach ends up being really helpful, because we should just realize that we know a lot less than we know.
So I'm curious, have you thought or even cared about trying to do something similar for another sport? And
So,
like, I'm just thinking of the wild world of Major League Baseball draft, which is basically like, it's like an auction draft in a way with the weird structure. But have you looked at this for other sports at all? Thought about?
So baseball, I think some teams have done it. I think ultimately it's just really hard. I think number one, the issue is that most sports don't lack this kind of crazy draftnik community that the NFL has. So I think that's part of it, is that you don't get as much of a sample size, or you don't get as much of a kind of variation in thought. And the MLB draft is really difficult because there's this signability question, and a lot of it is just unknown. It's changing all the time. We also have a much bigger prospect pool because we have these high schoolers who are eligible. And in some ways you have a similar problem in hockey. It's going to be probably a little bit more comparable to the NFL draft. Even if they decide to go back to school or to juniors in hockey, the team still owns their rights. But in baseball, signability is huge, because if you don't sign, you go back in the draft pool. There was some writer, I think, or a researcher for, I think, Sports Logic in Canada, who did something kind of similar to what I did for the NHL. I think it was interesting. I think the real interesting one is probably the NBA. The draft pool is a lot smaller. There's a lot fewer picks. The prospect pool is a lot smaller. You might be able to get some pretty good predictions out of that. And I think that's probably the best sport in terms of the kind of, I think could benefit from this type of approach. I just don't have as much time, and I don't have as much passion about the NBA draft. The other thing in the NBA draft that's kind of interesting, and I guess also in the NHL draft, is the quality of play across the leagues. I guess it exists in every single draft when you come to think about it. Mm-hmm. I think it's very different in the international, when you add an international component too. In the NFL, everything is American, it's domestic, it's standardized and accessible. So I still think the NFL is probably the one that has the best database for it. But I think in terms of the structure of the actual draft, the NBA draft is the one that I think would probably get you the best predictions, just because of the nature of the draft, of how small it is, and the prospect pool is not as huge.
Yeah, I think you really hit the point dead on of thinking of, I mean, the type of variation you could see in NFL mock drafts, right? And the bottom line is, we are living in an NFL world. We talk about it nonstop all year versus other sports, at least in my opinion. But Costas, do you have any other questions you want to ask before wrap up here?
I think the last question, you talked a little bit about the data collection process and where you start, when you started and stuff like that. So can people find the first part, the prototype that you use for the Carnegie Mellon, if they want to play with it? So how can they get access to that?
Sure. It's the reproducible research competition. So they require a repo, and because the data from 2018 is much more of a proof of concept, it's up on a Bitbucket repository. And so I can send you guys the link to it, and you can include it in the show notes, and people can play around with the data. The data set includes, I want to say, the mock draft data. It includes a file of players to exclude from the mock draft data who weren't draft eligible or who declared to return to school. It includes the actual 2018 draft results. It includes a data set of the model predictions, and it includes a data set of the Pro Football Reference approximate value data that I have for those players, so that you can kind of look at at least at the time. I think this is from last year, so there'll be a third year of data that you put. That data set is out of date. we've learned a new year of data about those guys since then. But yeah, that data all exists in the repo, and people can definitely create their own models with it and play around with the 2018 data as much as it is.
Fantastic. And as you brought up, we actually recently just launched the abstracts are now, we're calling abstracts for the reproducible research competition this year. Deadline is September 3rd. And partly because of work you've done in the past and other entries, we decided to create 2 separate tracks, a method track focus, and now a new sort of data contribution, software contribution. Just thinking of like the work you did even in a few years ago before last year's submission that really focused on all of this mock draft data that people weren't accessing or using before. So we're really excited now to try to like even highlight that more distinctly and reward those people that hopefully even create things like R packages for accessing new data and whatnot. I'm just curious, any recommendations or helpful tricks, hints for people in their submissions for entering this competition, given that you are indeed a finalist and I think it was honorable mention the year before as well. So you have a proven track record. What should people think about if they're looking to enter this year?
So the number one thing that I really like about the Carnegie Mellon Sports Analytics Conference, beyond the fact that they've allowed me to present some of my work, which is I'm really grateful, because I think that the CMSAC conference is really unique in the sports analytics kind of conference world, in that students are really invited and thought of in the design of the conference. And also there's this ability for people who are kind of outsiders, who aren't in academia, who aren't in industry. If you have an interesting idea that is unique potentially and is an interesting application of some things, that you can have your ideas heard and seen. Even, like I said, last year I wrote the paper. I read the whole paper. I hadn't written a paper since 2014 when I got my master's degree, and so I had to sweat it out in writing the paper. But then you have it out there, and having the opportunity to present in front of a bunch of different people was a great opportunity for me. And so, in terms of my kind of advice about writing, number one, I think it's a good idea to submit something. Because I thought my thing was a little interesting, and it turns out other people did too. And so it was a great opportunity. So to me, I think number one, having it's hard to find a unique idea, but find something that you're interested in and a question in a data set. I think highlighting the kind of software and the data side of things is really laudable, because there's a lot of people who are just interested in the data. I mean, you should know, Ron, as one of the originators of the NFL scraper package, that having data access is really helpful in being able to do analysis and do research. And so, there's
and it's
all
an
kinds
incredible amount of work to maintain those types of things as well.
Yeah. So there's a guy named Siam Galani, I think, Galliani, and I'm sorry, I'm probably mispronouncing his last name, who has done a lot of work around standardizing, and the data engineering stuff is really underrated in that way of creating access and repositories. There's so much more data out there than you think for a lot of sports topics. So last year in the Reproducible Research Conference, for the undergraduate side, there were some really impressive papers with basketball data, and then there was even, I think, someone who was doing swimming, which was pretty cool. So there's all kinds of sport. Yeah, Pitt student, exactly. Another Pitt student. So there's a lot of interesting data out there, a lot of interesting questions. Go seek that data, go ask those questions. And I think that the Carnegie Mellon Sports Analytics Conference is a really welcoming place to all different types of folks to present their research.
Awesome. Well, thank you for the kind words about the conference, Ben. And Kostas, do you have anything to add? Or?
No, I think that was great. Great information.
All right. And so just as a reminder for people, you can follow Ben at benj_Robinson. Check out the grindingthemocks.com, as well as the Twitter handle at grindingmocks. for his project and follow it along the year. Obviously, it's a bit early right now, but it's always draft season in our hearts.
Yeah. I will be releasing preseason rankings in early September as the season starts. So be on the lookout for those.
Awesome. Well, thank you, Ben, for joining us, and thank you all for listening. As I indicated on Twitter, this is technically the season 1 finale because there are only 8 episodes in the Skywalker saga Star Wars. There's never been an episode 9. We don't talk about it. So season 2 info will be coming shortly. So stay tuned. Follow us on Twitter at Open Source Sports. And then also make sure to check out on iTunes or whatever Apple Podcasts, Spotify. Feel free to rate and review. You can say how annoying I am, and how great Ben was, and how great of a co-host Costas is, and whatnot. Feel free to share all your thoughts. All feedback welcome. But thank you, Ben, for joining us.
Thank you for having me.